Welcome to the deep dive. We've got quite a stack of sources you sent over about some pretty advanced tech hitting law enforcement.
Yeah, it's definitely generating buzz. We're digging into the AlphaVision AI platform today.
Right. They're showcasing it at the IACP conference in Denver soon, October 18th to 21st.
That's the one, International Association of Chiefs of Police. And AlphaVision isn't just calling it software. They've branded it the Physical Superintelligence Platform.
Physical superintelligence. Okay, yeah, we definitely need to unpack that. Lots of capitalization there.
Yeah, indeed.
So our goal today is to cut through that, marketing speak. What actually is this platform? How's it supposed to work in the real world?
And what does it mean for things like solving cases or even predicting crime?
Exactly. Get to the core function.
Well, we do have a pretty clear mission statement from their CEO, Song Cao. He's a Ph.D.
Okay, what's the quote?
He says the mission is to help law enforcement close cases faster and prevent crime before it happens.
Prevent crime before it happens. That's the really ambitious part, isn't it? That proactive element.
It absolutely is.
Oh.
And it seems to be the guiding principle behind the whole system.
All right, so let's break down this architecture. AlphaVision says they're leaders in AI for physical security, video intelligence. But superintelligence needs more than just cameras, right? What's the foundation here?
It really comes down to the integration of three key technical components working together. Think of it like a three-legged stool.
Like one.
First, you've got what they call autonomous AI agents. These are basically digital partners for police departments.
Digital partners, meaning?
They're designed to handle the constant analysis of incoming data streams, sort of the tireless digital workers.
Okay, it sounds powerful. But if the agents are the brains doing the analysis, what's the feature that actually, speeds up the investigations themselves, the thing they keep highlighting?
That would be magic search. That's the second leg. It's critical because it lets investigators search through massive amounts of video really, really quickly.
Faster than just scrubbing through footage.
Way faster. It moves beyond simple keyword searches. It's about finding specific visual evidence almost instantly. Turns hours of review into seconds, supposedly.
Okay. Agents doing analysis, magic search for finding evidence.
Yeah.
What's the third leg holding it all up? The thing connecting everything across, say, a whole city.
That's the unified database. And it's more than just storage. It's the connective tissue.
Connective tissue.
How so? It's designed to pull in data from all sorts of different sources, city cameras, maybe private security feeds if they opt in, other municipal systems, and then normalize it.
Normalize meaning.
Yeah.
Make it all speak the same language.
Exactly. So it can correlate evidence, spot patterns across these previously incompatible systems, and deliver intelligence in real time.
Okay, I have to jump in there. A unified database sounds great in theory, but, city IT.
Yeah.
It's often a patchwork, right?
Yeah.
Decades-old systems, different camera brands, departmental silos.
Absolutely.
How realistic is it to get all that truly unified and talking in real time?
Look, that is the million-dollar question, and it's the core technical challenge they claim they're solving. The sources suggest they use some pretty sophisticated data normalization techniques.
So layers of software to translate everything.
Essentially, yes, to standardize the inputs from traffic cams, body cams, private CCTVs, whatever's connected. The goal probably isn't perfect unification overnight, but creating a common operational picture for intelligence analysis. It's a massive task.
Understood. A huge undertaking. Okay, let's circle back to those autonomous AI agents. It's not just one AI, right? They mentioned a suite at IACP.
Correct. They're showcasing specific agents. AI Inspector, Virtual Guard, Magic Search, which seems to be both a feature and an agent, interestingly, and something called AGI mode.
Okay, so AI Inspector, Virtual Guard.
Mm-hmm.
What's the difference? How do they function?
It seems to be about timing and focus. The virtual guard is the real-time, proactive one.
Like a digital security guard watching feeds.
Kind of, yeah. It's constantly monitoring for anomalies, things that deviate from normal patterns. A car going the wrong way down a one-way street, maybe a large crowd forming unexpectedly near a secure building, a package left unattended, that kind of thing.
So the guard spots something unusual and raises an alert.
That's the idea. Then the AI inspector comes in more for the post-incident analysis.
Okay. After the fact.
Right. Once something has happened, the inspector gathers all the relevant data points, confirms timelines, checks against historical data, looks for connections to other incidents or known patterns. It pieces the puzzle together after the event.
Got it. Guard watches, inspector investigates. What about that AGI mode, that term, AGI, artificial general intelligence? That usually means like human-level AI.
Yeah.
Sounds like marketing type.
Oh, it's definitely high-level marketing language, no question.
Yeah.
But in their context, AGI mode seems to point towards their future goal, their roadmap.
Oh.
It likely represents the aspiration for these separate agents, the guard and inspector, to eventually integrate their functions much more deeply, to learn from the citywide data and perhaps make connections or recommendations beyond their initial programming. It's signaling their ambition for more advanced machine learning down the line.
Okay, makes sense. A future goal, not a current reality. Let's shift to magic search then. This seems to be where the rubber meets the road, the immediate practical application.
Yes, solving things like smash and grabs, bomb threats, identifying crime patterns. This is the tool for that.
What's the actual tech behind it? How does it search so fast? Is it just indexing everything?
It's more sophisticated than just indexing. It uses advanced machine learning, specifically for visual attribute recognition, and importantly, natural language processing, or NLP.
Natural language, so an investigator can just talk to the system or type like they're talking.
Pretty much, yeah. Instead of complex futures, an officer could type something like, "Show me anyone wearing a blue jacket and carrying a red bag near the main library between 2 p.m. and 2:15 p.m. today."
And the system understands that.
The NLP interprets the request, translates blue jacket and red bag into visual attributes, and then the AI scans potentially petabytes of video data, tagging the relevant frames almost instantly. That's the speed factor.
Okay, that explains the case study from Layton, Utah, the bomb threat. High stress, time is critical. They used magic search, resolved it in minutes. How did that play out with the attribute search?
Well, the key was searching and tracking across multiple city cameras simultaneously. They didn't have to rely just on eyewitnesses or manually pull feeds from different locations.
They just put in the suspect description.
Exactly. Clothing, maybe direction of travel, whatever details they had. Magic Search then tracked the individual across the network.
And found them.
It located them quickly and confirmed their movements. Crucially, it helped determine the threat was actually a hoax because they could see the person's actions and location in near real time.
So that speed and precision de-escalated the situation rapidly, avoided prolonged panic.
That's the takeaway from that example. Speed and precision in a localized, time-sensitive crisis.
Okay, that's one type of incident. But what about something much more complex, like organized crime? The example from San Ramon, California, a $1 million jewelry heist, 25 armed suspects. That's not just finding one person quickly.
No, that requires a whole different level of analysis, connecting dots across a huge data set.
So how did Magic Search help there? It wasn't just finding footage of the heist itself, right?
Correct. This is where the superintelligence concept, or at least the platform's power, comes into play. They used it to search for attributes related to the getaway vehicles, maybe specific clothing items worn by different suspects, even patterns in how they moved or operated across different times and potentially different locations or jurisdictions.
So it wasn't just finding footage, it was linking footage.
Yeah.
Linking this crew to more than just the San Ramon job.
Exactly. The system helped connect the individuals, their vehicles, their methods to multiple coordinated robberies. It identified those subtle, shared patterns that showed it was an organized group.
That makes sense. Finding the pattern, not just the single event.
Right. And as the co-founder, Yi Jin, put it, in these big, complex cases, time equals safety. Being able to quickly link a crew like that potentially stops them before they hit the next target.
That's a really crucial distinction, moving cameras from just being passive recorders.
To active defenders, as CEO Song Cao said, using the data to detect and even deter organized crime. It's a shift from reactive evidence gathering to more proactive intelligence.
Which perfectly sets up the next part, their future roadmap, what they're calling the Physical Superintelligence Platform Roadmap.
Yeah, they outlined 3 major capabilities they plan to showcase or discuss further at IACP.
Let's take them one by one. First up, AI-driven case management. Sounds like making paperwork easier.
Essentially, yes. It's about automating the grunt work of compiling case files. The system would automatically generate reports, pulling together the relevant video clips, timestamps, metadata about the incident, maybe linked suspect info.
All into a court-ready format.
That's the claim. Structured files ready for review and submission.
Okay, but wait. Court admissibility. That usually involves really strict chain of custody, human verification of timestamps, metadata integrity. How does an automated system guarantee that? Isn't there a risk the AI makes a mistake in compilation?
That's a critical point and a legal and technical hurdle. Their argument likely rests on the unified database itself.
How so?
If the data is ingested, timestamped, and logged rigorously within that unified structure from the start, the system maintains a supposedly auditable digital trail for every piece as evidence. The AI does the initial compilation, saving investigator time, but the human still needs to audit and verify before submission. It shifts the human role from data gathering to data validation.
Okay, so it streamlines but doesn't eliminate the human verification step. That makes more sense. What's next on the roadmap? This sounds like the most forward-looking one. The predictive analytics engine.
Right. This directly ties back to that mission of preventing crime before it happens.
How does it work? What's it predicting?
It uses pattern-based machine learning models. It analyzes all the aggregated data in the unified database, past crime locations, times, types of incidents, maybe known offender movements, even environmental factors like weather or events.
To try and forecast where and when crime is likely to occur, spotting hotspots before they fully emerge.
Exactly. Or identifying emerging trends, like a new type of theft picking up steam, or even potentially flagging repeat offenders whose patterns suggest escalating risk.
So the actionable intelligence for a police department would be alerts, like, hey, Area X shows a high probability for burglaries this week based on factors A, B, and C.
That's the concept, allowing departments to deploy resources more proactively, maybe increase patrols in a predicted hotspot, or focus investigative resources based on emerging patterns, using historical data to predict future probabilities.
The potential efficiency gain there is obvious, predicting where to focus resources, identifying potential risks early.
It's undeniable.
But this predictive analytics engine, this is where the really big questions come in, ethically and practically, right?
Absolutely. Predictive policing is, well, it's a complex and controversial area.
While the stated goal is ethical, transparent intelligence reinforcing traditional policing. How do you ensure that? How do you prevent biases in the historical data from just reinforcing themselves in the predictions?
That is the central challenge. If algorithms are forecasting where crime might happen or who might reoffend, there needs to be absolute transparency about the data being used, the logic of the algorithm, and rigorous oversight to prevent bias and ensure fairness.
It's that balance, isn't it? The push for efficiency and prevention versus the absolute need for transparency and equity in how these tools are used.
Precisely. That balance will define how agencies adopt and manage this kind of technology. Machine speed is one thing. Human wisdom and oversight are critical.
Okay, one last piece of the roadmap.
Yeah.
To make all this work across jurisdictions, you need data sharing. What was the third capability?
The Interagency Data Exchange, or IADX.
So breaking down silos between different police departments or even state agencies.
That's the goal. Creating secure, verified channels so that intelligence gathered by, say, San Ramon PD could be instantly and securely shared with neighboring cities or county sheriff's offices if a suspect or situation crosses jurisdictional lines.
Achieving truly unified situational awareness across a region.
Right. Which, again, is technologically and politically complex. It requires not just the tech platform, but solid agreements on data governance, security protocols, and interagency cooperation.
Another massive undertaking. But you can see how it would multiply the effectiveness of the AI agents and the predictive engine if they pull it off.
Definitely. It shifts the platform from a single city tool to potentially a regional enforcement network.
Okay, so let's recap for you, the listener. We've looked at the core of Alpha Vision. These specialized autonomous AI agents doing the analysis.
The challenge and importance of that unified database trying to make sense of disparate data sources.
And the power of magic search. We saw how it can provide that speed for resolving immediate crises, like the Utah bomb threat.
And also the deeper analytical capability to connect dots and track organized crime, like in the San Ramon heist.
And we've touched on that fundamental shift, viewing cameras not just as passive recorders after the fact, but as active intelligent sensors, feeding a system designed for proactive defense.
Transforming passive history into active intelligence.
Which brings us right back to that big final question, especially concerning that predictive analytics engine. If these platforms really get good at forecasting hotspots, predicting trends, maybe even flagging potential repeat offenders before they act, how do we as a society balance that incredible potential efficiency, the drive to prevent crime before it happens, with the non-negotiable need for transparency, fairness, and rigorous oversight in our public safety system?
That tension between predictive power and public trust, that's the critical conversation we need to keep having as this technology rolls out.